I am S. MOHANAPRIYA, Assistant Professor, Department of Mathematics from KSR College of Arts and Science for Women, Tiruchengur. The topic is Real Analysis 2. Now we discussed about closed set. A set S in I r power n is called closed if it is complement of I r power n in S is open. For example, every closed interval a comma b is closed. An empty set pi is both open and closed. Now metric space. Let M be any set. A metric space M is a function and within domain M cross n and the range of 0, infinity. And then 4 conditions are satisfied in metric space. Rho of x comma y equal to 0 for every x belongs to M. Second one, rho of x comma y greater than 0 for every x and y belongs to M, then x not equal to y. Rho of x comma y equal to rho of y comma x. Rho of y comma x less than or equal to rho of x comma z plus rho of y comma z. Then x y z belongs to M. This is a triangle inequality conditions. Next we discussed about compact metric space. A metric space is a compact if every open cover of the space has a finite subcover, then every sequence in the space has a subsequence that converges in a space. A non-empty set y of x is said to be a compact if it is compact as a metric space. For example, a finite set in any metric space x comma d is compact. In particular, a finite subset of a discrete metric x comma d is compact. Next, connected set. A connected set is a set that cannot be divided into two non-empty subsets that are open in the relative topology of the set. For example, any interval of real number is connected. The real or complex plane is connected. Next we discussed about bounded set. A set that has both upper and lower bound that are set bounded above and bounded lower is known as bounded set. So for being a bounded set, there are two number n and capital N for which n less than or equal to x less than or equal to n for any x belongs to A. If this condition satisfies that set A, then A is called bounded set. Next we discuss about complete metric space. A complete metric space is a metric space where every Cauchy sequence of a point has a limit point is also in the space. Next, totally bounded set. A subset A of a metric space is called the totally bounded if for every r greater than 0, A can be covered by a finitely many open ball of radius r. A subset S of a uniform space X is totally bounded if and only if for any integer E. There exists a finite cover of S by subset of X. For example, a bounded subset of the real line is totally bounded and some bounded set for all numbers between minus of root 537 and pi 25 by 17 for all positive rational number whose square is less than 2. Continuity of the inverse function. A function f is continuous, then its inverse function f inverse is also continuous. Here some of the other properties of inverse function. If n increasing and decreasing means, then f dash is also increasing and decreasing. If f is differentiable at c and f dash of c not equal to 0, then f inverse is differentiable at f of c. Uniform continuity. Uniform continuity of a real function is usually defined in terms of limit. A function f with x is continuous at the real number c if the limit of as x tends to c is equal to 0. There are several different definitions of the continuity of a function which depends upon the nature of its domain. Thank you.